Hello and welcome. Tonight, we're stepping beyond the boundaries of the present moment into a realm where past, present, and future blur together like brushstrokes on the same canvas. This is the story of time travel, why we dream of bending the clock's arrow, how philosophers and scientists have wrestled with its possibilities, and what it reveals about the way we see ourselves. So if you're ready to unwind, settle in, and let your thoughts drift across centuries and light years, make sure to subscribe and turn on notifications so you'll never miss another journey through the infinite landscapes of the mind. Now, let's begin. Imagine, for a moment, that you could step outside the constant, unbroken stream of time. Imagine holding a remote control for reality itself, with buttons to rewind, fast forward, or pause the very fabric of existence. Imagine being able to revisit the happiest day of your life, to walk once more through familiar streets that no longer exist, or to leap forward to witness the rise of cities not yet built, to see faces of people who are still only ideas in the minds of the future. It is a thought so intoxicating that it has been with humanity for centuries, perhaps for as long as we have had the ability to imagine at all. Time travel is not merely a trope of science fiction. It is a concept that has captivated philosophers, physicists, storytellers, and dreamers alike. It is both a deeply personal fantasy, the hope of undoing mistakes, rekindling lost moments, or glimpsing futures we will never live to see, and a cosmic puzzle that challenges the way we understand reality itself. Even now, as you listen, you are engaging in a subtle form of time travel. The memories you call upon, the possibilities you imagine, are journeys away from the present moment. They may not alter the events themselves, but they alter you, the traveler, in ways you might not notice until long afterward. The allure of time travel is anchored in two of our most human traits: curiosity and regret. Curiosity pushes us forward. It makes us wonder about the cities of the year 3000, about whether humanity will walk among the stars, about whether our descendants will speak our names with pride, or not at all. It whispers to us questions we cannot answer from here. What technologies will exist? Will our greatest challenges, hunger, war, disease, be solved, or replaced by even greater trials? What will the skies look like, and will they still belong to Earth? Regret, on the other hand, pulls us backward. It takes us by the hand and leads us through moments we wish had gone differently. It replays conversations in our minds, lets us linger in days we took for granted, and forces us to wonder how a single different choice might have changed everything. The past, as we know it, is unchangeable, yet we return to it again and again, as if by thinking about it hard enough, we might somehow move its pieces around. Time travel, in the way we dream of it, promises to satisfy both impulses, to feed our hunger for the unknown that lies ahead, and to soothe the ache for what lies behind. Before we talk about time travel as physics or philosophy, it is worth remembering that we already practice it, in a way, every single day. Our minds are extraordinary machines for visiting other times. Neuroscience has shown that the brain can reconstruct past events so vividly that they feel almost indistinguishable from the original moment. The same mechanisms allow us to project ourselves into imagined futures, walking through days that have not yet happened. This mental time travel is one of the defining features of human cognition. It allows us to learn from the past, to prepare for the future, and to imagine possibilities far beyond the present moment. Think of the times you've replayed a moment in your head, wondering how it might have gone if you'd said something different. Think of the days you've spent picturing an upcoming trip, a meeting, or a milestone. These are rehearsals of life, journeys your mind takes across the map of time even though your body remains still. It is perhaps no wonder then that the idea of physical time travel, of moving not just in thought but in reality, has such a powerful hold on us. If our minds can leap through years in an instant, why shouldn't our bodies follow? Why shouldn't the whole of reality be able to shift with us? The stories we tell about time travel often reveal what matters most to us. Some are about reunion, meeting loved ones long gone, or even ancestors we never knew. Imagine standing in the home of a great-grandparent, seeing them as they truly were, hearing their voice for the first time. Others are about discovery, exploring strange futures, walking among landscapes transformed by centuries of change, or witnessing the birth of civilizations we will never live to see. And some are about redemption, returning to avert mistakes, to prevent disasters, to offer kindness where once there was neglect. Each of these stories taps into something primal, our awareness that time is the one thing we can never hold, and our longing to somehow escape that truth. There is also, deep within the idea of time travel, a quiet rebellion. Our everyday lives are built on the assumption that time flows in one direction and at one pace. We cannot slow it. We cannot reverse it. We cannot leap ahead. Time travel challenges that assumption. It suggests that the rules might be different than they appear, that perhaps the future is not unreachable and the past not entirely lost. To travel through time would be to take hold of something untouchable, to break the single law that seems to govern everything. It is a fantasy of control over the uncontrollable, and in that sense, it is the ultimate human dream. This dream is not unique to the modern age. Cultures around the world, separated by oceans and centuries, have told stories that echo the themes of time travel. In ancient Indian epics, heroes journey to distant realms where time flows at a different pace, returning to find that centuries have passed in the world they left behind. In Japanese folklore, the fisherman Urashima Taro visits an undersea palace and stays for what feels like a few days, only to emerge and discover that hundreds of years have slipped away. In Irish legend, Oisin rides to Tir na Nog, the land of youth, only to find that the moment he touches the soil of his homeland again, the weight of centuries falls upon him. These stories, and many more like them, suggest that the longing to step outside the normal flow of time is as old as storytelling itself. Modern science gives the dream a new language. Where ancient myths spoke of enchanted kingdoms and magical artifacts, we speak now of wormholes, relativity, and quantum entanglement. We imagine bending space-time itself, folding distant points together until past and future sit side by side. Yet for all the mathematics and theories, the questions we ask remain deeply personal. If time travel were possible, would you meet your past self? Would you try to change something, or would you simply watch, unseen? Would you risk looking into your own future, knowing you might not like what you find? In the end, our fascination with time travel may be less about clocks and calendars, and more about the human experience of time itself. We feel its passing in every change we cannot undo, in every anticipation that pulls us forward. We dream of time travel because we dream of mastery over our lives, over our choices, over the very story we are living. And yet, perhaps, if we could truly bend time, we would discover that its value lies precisely in the fact that it cannot be bent. That is the allure of time travel. It is both a promise and a warning, a longing and a fear. It is the hope that somewhere, somehow, there is a way to keep the moments we love, to avoid the mistakes we dread, and to see the wonders that await us beyond the horizon of the present. And it is the knowledge that time, whether we master it or not, will always carry us forward into futures unknown. When we imagine traveling through time, we often picture it as a kind of journey through space. We see ourselves stepping into a machine, feeling it hum to life, and watching the world outside blur as years collapse into moments. But time, unlike space, is not something we can see or touch directly. It is experienced in the rhythm of our breathing, in the slow weathering of stone, in the way a shadow shifts across the ground. To dream of traveling through time is to dream of moving through an invisible ocean where the currents are steady and unstoppable, and where our small vessel is usually powerless against the tide. The idea that we might set our own course against those currents feels like a miracle. Even in our ordinary lives, we feel the pull of this miracle. We slow down when we want a moment to last, lingering over a meal, holding the gaze of someone we love, walking slowly through a place we may never visit again. And yet, no matter how carefully we try to savor these moments, they slide away from us. The ability to truly stop them, to freeze them like an insect caught in amber, would give us a kind of freedom we can only imagine. This is why, in so many stories, time travel is not just about going to another era. It is about reclaiming control over life itself. But time travel also carries a shadow. If we could revisit the past, would we resist the temptation to change it? We like to imagine that we would only make small adjustments, saving someone from an accident, avoiding a wrong turn, choosing a kinder word. But the smallest change could ripple outward, altering events we cannot foresee. A life saved might lead to a life lost elsewhere. A disaster averted might erase the very circumstances that led you to the moment you are in now. And so time travel stories often carry a warning. The past is not a thread to be neatly rewoven, but a web where every strand is connected to countless others. Our fascination with these possibilities has only grown with each generation. In the 19th century, when steam engines were shrinking distances and telegraphs were shrinking the time it took to send a thought across continents, writers began to wonder, if we can move so quickly across space, could we also move quickly through time? H.G. Wells's The Time Machine gave us one of the most enduring visions. A mechanical vessel gliding silently across centuries, allowing its traveler to watch the rise and fall of civilizations as if turning the pages of a book. The power of this story was not only in the machine itself, but in the sense of scale it gave to human life. Suddenly, our brief existence could be placed in the context of millennia, making our joys and sorrows seem both precious and small. In the 20th century, as our understanding of physics deepened, time travel took on new layers of complexity. Albert Einstein's theory of relativity revealed that time is not an absolute universal clock, but something that bends and stretches, depending on speed and gravity. A traveler moving close to the speed of light would experience time more slowly than those they left behind. Suddenly, time travel was no longer just fantasy. It was, at least in theory, a feature of the universe itself. This scientific grounding made the dream feel closer, and yet more mysterious, because it suggested that time is woven into the fabric of space, and that pulling on one thread might reshape the whole tapestry. And still, beneath all the mathematics and science, the heart of the dream remains the same. We imagine stepping through a door and finding ourselves in another time because we want connection to the people who came before us, to the people who will come after, to the endless stream of moments that make up the story of the world. In our minds, time travel is a bridge. It is a way to stand in two places at once, to carry the knowledge of one era into another, to be both student and witness in the grand history of existence. There is also a strange comfort in imagining that time is not a straight road, but a vast landscape. If time can be traveled, then perhaps the moments we have lost are not gone forever, but waiting in some far-off corner, like towns along a winding path. This thought allows us to imagine that nothing is truly lost, only out of reach. It is an idea that has carried countless people through grief, through longing, through the slow passage of years. Philosophers have often wondered whether time itself is something that exists independently of us, or whether it is simply the way we perceive change. If the past and future are as real as the present, then traveling to them might be no more strange than walking to the next room. But if time is only a construct of our minds, then the act of traveling through it might be as impossible as stepping into a dream and expecting to bring back something tangible. And yet, dreams themselves have a kind of reality while we are in them, and perhaps, in that way, time travel will always belong as much to the imagination as to the laboratory. So we return to our thought experiment. You have the ability to step anywhere along the timeline of your life, or even beyond it. Where do you go first? Do you watch yourself as a child, learning to walk, unaware of the person you will become? Do you travel to a day you have never seen, a day long after you are gone? to see how the world remembers you, if at all? Do you go to a time before you were born to witness history not as words on a page, but as moments unfolding in front of you? In asking these questions, we reveal something important. Time travel is not just about when, but about why. The times we choose to visit in our imagination tell us who we are. The traveler who goes forward seeks hope, discovery, or perhaps warning. The traveler who goes back seeks closure, understanding, or a chance to set something right. In both cases, the journey is about finding meaning in the vast, unending river of time. This is why the idea has never left us, and likely never will. It speaks to our deepest desires and fears, to our longing for control and our acceptance that some things will always be beyond it. Time travel is a mirror we hold up to ourselves, showing us the value we place on our moments and the lengths we would go to keep them. And perhaps the greatest truth hidden in the dream of time travel is that we are already doing it. We move through time every second of our lives, carried forward whether we will it or not. We cannot jump ahead or loop back, but we can choose how to fill the moments we are given. In that sense, we are all travelers, and the road ahead, unknown as it is the greatest adventure of all. Long before the language of science gave us words like relativity, wormholes, and quantum mechanics, human beings were already dreaming of leaving the present moment behind. Across ancient cultures and distant lands, stories emerged of travelers who stepped beyond the ordinary flow of time. These journeys were often described in the language of magic or divine intervention, yet at their heart they reveal the same fascination that modern minds feel, the longing to see a world that is not now, to return changed by what was found there. One of the earliest known examples comes from ancient India, preserved in the great Sanskrit epics. In the Mahabharata, the hero king Kakudmi is said to have traveled to the realm of Brahma, the creator god, to seek guidance about finding a suitable husband for his daughter. To Kakudmi, the visit felt brief, only a few moments in the presence of the divine. But when he returned to Earth, he discovered that many ages had passed, and that all the men he had considered as suitors had long since died. Time in the realm of the gods moved at a different pace, and his short journey had carried him far into the future. This is not a machine-based voyage or a manipulation of physics, yet it contains one of the central themes of modern time travel tales. The idea that time can flow differently depending on where you are, and that the traveler may return to find the world forever changed. In Japanese folklore, there is the story of Urashima Taro, a humble fisherman who saves a turtle from harm. In gratitude, the turtle carries him to the undersea palace of Ryugu-jo, where he meets the beautiful Princess Otohime. He stays in this paradise for what seems to him like a few joyous days. When he finally wishes to return home, the princess gives him a mysterious box, warning him never to open it. But when he reaches his village, he finds it transformed. Everyone he knew is gone. The houses are strange. The language has shifted. Centuries have passed in what felt like moments. In despair, he opens the box, and a great cloud of smoke escapes. In that instant, he ages hundreds of years, his body catching up to the time he has lost. It is a haunting tale, one that captures both the wonder and the tragedy of stepping outside the normal flow of time. The ancient Greeks, too, were drawn to the idea of time's strange flexibility. Though they did not speak of time travel in the way we do now, their myths are filled with journeys to other realms where the usual rules no longer apply. The story of the hero Odysseus, as told in Homer's Odyssey, is not about leaping centuries in an instant, but it is about returning home to find the world altered by time. After years of war and wandering, Odysseus steps back into Ithaca, and the life he left is unrecognizable. His absence has transformed relationships, power, and the fabric of daily life. In this sense, the long journey serves as a mirror to the traveler's own transformation, a theme that will echo through countless later stories. In the Celtic tradition, time slips are common in tales of visits to the other world. The Irish legend of Oisin tells of a warrior who falls in love with Niamh, a woman from Tir na Nog, the land of youth. He rides with her across the sea to her home, where there is no aging, no sorrow, and no death. They live together in happiness. But after what seems to him only 3 years, Oisin grows homesick and decides to visit Ireland once more. Niamh warns him not to set foot on the ground when he arrives, but when he returns, he finds that hundreds of years have passed. Ireland is a strange land filled with strangers. In a moment of compassion, he leans from his horse to help lift a heavy stone, and as soon as he touches the earth, the centuries catch up with him. He becomes an old man in an instant, the weight of all those lost years pressing down. Stories like these serve many purposes. They warn against leaving the safety of the known world. They suggest that time is not a single steady river, but a series of currents that can move faster or slower depending on where you drift. They offer the hope and the fear that the present moment is not as fixed as it seems. Even religious traditions contain echoes of this theme. In Islamic tradition, there is the story of the Isra and Miraj, in which the Prophet Muhammad is said to have been taken on a miraculous night journey, traveling first to Jerusalem and then ascending through the 7 heavens. Though the focus of this story is spiritual rather than temporal, the journey compresses extraordinary distances and events into a single night, suggesting that divine will can bend both space and time. In the Norse sagas, there are hints of temporal displacement as well. The sagas speak often of journeys to other worlds, to the realm of the gods, to the land of the giants, or to Hel, the world of the dead, where time flows differently than in the world of men. Though these tales often mix the language of myth with that of fate, the idea that the traveler returns to find the world changed is a recurring thread. Perhaps what is most striking about all these early visions of time journeys is how closely they resemble our modern imagination of time travel. The details differ. There are no brass levers, blinking consoles, or mathematical formulas. but the emotional core is the same. The traveler leaves their own time, enters a realm where time works differently, and returns to discover that they have been transformed, and so has the world they left. Ancient myths also remind us of something important. Time travel, in its earliest forms, was not about science, but about meaning. The journey was rarely undertaken for curiosity alone. It was a test, a reward, a punishment, or a calling. It revealed truths about the traveler and their place in the world. And this may be why these stories endure. We still read them, tell them, and adapt them because they speak to something deeper than the mechanics of time. They speak to the human experience of change, loss, and transformation. From these myths, we can trace a line forward through the centuries to the moment when scientific thinking began to offer its own visions of time travel. But even then, even in the age of telescopes and equations, the heart of the idea would remain the same, the dream of stepping beyond the now and seeing what waits beyond its edges. The transition from myth to philosophy was not sudden. For centuries the two overlapped, with ancient thinkers blending the poetic with the analytical. Philosophers in Greece, India, and China pondered the nature of time long before they had the means to measure it precisely. They observed the movement of the sun, the phases of the moon, the turning of the seasons, and tried to understand whether time was a thing in itself or simply a measure of change. In ancient Greece, the philosopher Heraclitus famously declared that you cannot step into the same river twice. He was speaking of change, of the way all things flow and shift. But his image captures something essential about time travel as well. If you could go back to a moment in the past, would it truly be the same? The river might be in the same place, but the water has moved on, and so have you. Plato, in his Timaeus, described time as a moving image of eternity. To him, time was not an independent entity, but a reflection of the eternal, tied to the movements of the heavens. This view meant that any journey through time was, in a sense, a journey through the cosmic order itself, not a small thing to undertake. Aristotle, more grounded in the physical world, defined time as a measure of change in relation to before and after. This way of thinking laid the groundwork for later scientific approaches, even if the idea of physically moving through time remained in the realm of story and speculation. In ancient India, philosophical traditions such as those found in the Upanishads also wrestled with time's nature. Some schools saw time as cyclical, an endless wheel of creation, destruction, and rebirth. In such a worldview, time travel might not be a matter of moving forward or backward, but of stepping into another turn of the wheel, a different cycle that is nevertheless part of the same eternal pattern. This cyclical view appears in myths, like that of Kakudmi, but also in countless smaller stories, where travelers move between ages as easily as stepping across a threshold. In China, early Taoist and Buddhist texts offered their own visions. The Taoist classic Zhuangzi tells stories in which the boundaries between waking life and dream, past and future, blur until they lose all meaning. In some tales, A single night's dream can encompass years of living, only for the dreamer to wake and find no time has passed at all. Such stories play with the idea that time is subjective, experienced differently depending on one's state of mind. A theme that modern science, with its study of relativity and perception, would later echo. What these ancient philosophies and myths share is an openness to the idea that time is not fixed. It can be sped up or slowed down. It can loop back on itself or stretch forward into vast distances. And it can be experienced in ways that are not the same for everyone. In this sense, the ancients were already exploring the same questions that physicists and storytellers continue to ask today. One of the most enduring features of early time travel tales is their moral dimension. These were not casual adventures. The traveler's journey through time often came at a cost, whether in years lost, relationships altered, or truths revealed that could not be unlearned. Urashima Taro gains a glimpse of paradise, but loses his place in the world he knew. Oisin finds love and eternal youth, but at the cost of everyone and everything familiar. Even the heroes of the Mahabharata, when they encounter time's strangeness, return to a world they can no longer fully call home. This pattern tells us something about how early cultures understood time. It was not a neutral backdrop, but an active force, one that could bless or punish depending on how it was approached. In many myths, tampering with time, even accidentally, was dangerous. It could leave you stranded, alone in an unfamiliar age, or burdened with knowledge you could not use. These cautionary elements have survived into modern time travel fiction, where the traveler's actions often have unforeseen consequences. And yet, for all the warnings, the longing to cross time's boundaries remains. Ancient listeners must have felt the same shiver of excitement that we feel today when a story promises to carry us to another age. They must have wondered, as we do, what it would be like to stand in a world that is gone, or to see a world that does not yet exist. By the time we reach the dawn of the scientific age, the old myths had not vanished. They continued to be told and retold, even as explorers mapped the globe and astronomers charted the heavens. In many ways, they provided the imaginative fuel for the thinkers who would later turn their attention to time itself. For if a fisherman could return from the sea to find centuries had passed, or a king could leave the presence of a god to find his world transformed, then perhaps the impossible was not so far from the possible. These ancient visions of time travel may not involve machines or mathematical equations, but they capture the essence of the idea. They remind us that time is not just something we measure with clocks, but something we live, and something that shapes us as much as we shape it. And they show that the dream of moving through time in one form or another has been with humanity from the beginning. From here, the story of time travel will begin to change. The age of myth will give way to the age of reason, and the storytellers will be joined by scientists. But even as theories grow more complex and technology more advanced, the same questions will echo through every age. What would you see if you could step beyond the present? And perhaps more importantly, who would you be when you returned? Time has always been one of philosophy's most elusive subjects. It is everywhere, touching every moment of our lives. yet it slips through our fingers the instant we try to hold it. We can measure it, mark it, and divide it into neat units. But what exactly is it that we are measuring? Is time something that exists independently of the world, like an invisible stage upon which events unfold? Or is it something that exists only in the changes we observe? Philosophers have wrestled with these questions for thousands of years, and their answers have shaped the way scientists and storytellers think about time travel. In the ancient world, Aristotle offered one of the earliest systematic examinations of time. For Aristotle, time was not a thing in itself, but a measure of change. Without change, there would be no time. If nothing moved, nothing aged, nothing shifted, then time would have no meaning. This view placed time firmly in the realm of the physical, tied to the motion of objects and the sequence of events. It also suggested that time was universal, the same for everyone, everywhere, because the motions of the cosmos provided a shared measure. In Aristotle's world, to speak of traveling through time would be to speak of moving through the ordered flow of nature itself. Centuries later, Saint Augustine of Hippo approached time from a more personal and theological perspective. In his Confessions, Augustine admitted that he could not easily define time, yet he felt its reality deeply. The past, he noted, no longer exists. The future does not yet exist. Only the present is real, and even that slips away as soon as we try to grasp it. For Augustine, time was something experienced within the human soul, a way in which we perceive God's creation. His view made time seem less like a physical dimension and more like a feature of consciousness, which, in a way, anticipates some modern debates about whether time is an objective reality or a mental construct. The question of whether time flows independently of events continued into the early modern period. In the 17th century, two great thinkers took opposing sides. Sir Isaac Newton, the architect of classical mechanics, believed in what he called absolute time. To Newton, time was a constant backdrop, flowing at the same rate everywhere in the universe, regardless of what happened within it. Events might speed up or slow down in our perception, but the underlying clock of the cosmos never wavered. This view made time seem like an invisible river running from the past into the future, carrying everything with it. Newton's contemporary, the philosopher Gottfried Wilhelm Leibniz, strongly disagreed. Leibniz saw time not as a thing in itself, but as a system for ordering events. If nothing happened, he argued, time would have no existence, much like Aristotle's earlier view. This disagreement between Newton and Leibniz foreshadowed the later debates that would arise in physics, when scientists began to question whether time was truly absolute. For nearly 2 centuries, Newton's view dominated. The equations of classical mechanics treated time as a uniform, universal coordinate, and this model worked well for everything from predicting the motion of planets to timing the fall of an apple. In this framework, time travel was difficult to imagine in any way other than moving faster or slower along the same universal timeline. A traveler to the past or future would simply be shifting position along a straight, unchanging axis. It was Albert Einstein who shattered that picture in the early 20th century. In his theory of special relativity, published in 1905, Einstein showed that time is not absolute. The rate at which time passes depends on your speed relative to other observers. A clock moving close to the speed of light will tick more slowly compared to a stationary clock. This effect, called time dilation, is not an illusion. It is a measurable physical reality. Suddenly, time was not a universal backdrop but a flexible dimension, intertwined with space in what came to be called space-time. Einstein's later theory of general relativity, published in 1915, took this even further. It showed that massive objects like stars and planets warp space-time itself, and that this curvature affects the passage of time. A clock closer to a massive object will run more slowly than one farther away. This gravitational time dilation means that simply by moving to different places in the universe, you could experience time at a different rate than someone else. In extreme cases, near the edge of a black hole, time for the traveler could slow almost to a stop compared to the outside world. These insights brought the dream of time travel into the realm of scientific possibility. If time can be stretched or compressed by speed or gravity, then in theory, a traveler could move into the far future simply by taking the right path through space-time. Traveling to the past remains far more complicated, and many physicists argue it may be impossible without violating other laws of nature. Still, Einstein's work opened the door to new kinds of speculation and inspired generations of scientists, philosophers, and storytellers to imagine ways it might be done. Philosophers, meanwhile, continued to wrestle with what these scientific revelations meant. If time is relative, does that mean past, present, and future all exist simultaneously in a vast four-dimensional block, as some interpretations suggest? This block universe view treats all moments as equally real, with our sense of time's flow being a product of our consciousness moving along the timeline. Others argue for a presentist view, where only the present moment is real, and the past and future are simply concepts. Each view has profound implications for time travel. In a block universe, traveling to the past might be a matter of moving to another location in space-time. In presentism, the past no longer exists to be visited, making time travel far more problematic. These philosophical debates reveal that even with Einstein's equations in hand, time remains as mysterious as ever. We can describe how it behaves, predict how it will affect moving clocks, and even test those predictions with high-speed jets and satellites. But the question of what time is, whether it is a thing, a relationship, or a perception, is still open. And until we understand that fully, the dream of moving freely through it will remain as much a philosophical challenge as a technological one. In this way, the journey from Aristotle to Einstein is not just the story of increasing scientific precision, it is also the story of our changing relationship with time itself. Once, it was a steady backdrop, ruled by the motion of the heavens. Then it became a human experience, tied to memory and anticipation. Then it became a universal coordinate, absolute and unyielding. until Einstein revealed it to be elastic, shaped by motion and mass. Each shift has brought us closer to imagining time travel not as magic, but as a possible feature of reality. And yet, each has also reminded us that the more we learn about time, the stranger and more elusive it becomes. We stand now in a world where our satellites must account for time dilation to guide us with GPS, where experiments confirm that time flows differently at different altitudes, and where the edges of black holes hold the key to some of the most extreme distortions of time in the universe. We may still be far from building a machine that can leap centuries in an instant, but the philosophical and scientific groundwork has been laid. The rest is a matter of discovery and of courage. For to step into time is to step into the unknown, carrying with us the same questions that have driven thinkers for millennia. What is time? Can we master it? And, if we could, should we? Every day, without fail, we experience time as something that moves. The sun rises, the hours pass, and night falls. Ice melts, smoke drifts away, and the seasons turn. We grow older, and we cannot return to the moments we have left behind. This constant movement from past to future feels so natural that we rarely question it. And yet, when we look closely at the laws of physics, we find something strange. Most of them make no distinction between forward and backward in time. On the deepest level, the universe's equations seem to allow events to unfold in either direction. So why then do we feel time as a one-way street? This one-way movement is often called the arrow of time. The British physicist Arthur Eddington popularized the term in the early 20th century, using it to describe the direction in which time appears to flow. While the equations of motion in classical mechanics or quantum theory may work just as well backward as forward, the arrow of time points unwaveringly toward the future in our everyday lives. The question is why? One of the clearest answers comes from the second law of thermodynamics, the principle that, in a closed system, entropy tends to increase over time. Entropy is often described as a measure of disorder, though a more precise way to think of it is as the number of ways a system can be arranged without changing its overall energy. In simple terms, there are far more disordered states than ordered ones, so as time passes, systems naturally evolve toward greater disorder. An ice cube in a warm drink melts, and the water molecules spread out. Smoke from a candle disperses into the air. Eggs break, but never unbreak. This growth of entropy gives us a natural distinction between past and future. The past is the time of lower entropy, when the ice cube was still solid, when the smoke was still concentrated, when the egg was whole. The future is the time of higher entropy, the melted ice, the dispersed smoke, the shattered shell. We remember the past precisely because it was more ordered. The traces of its order linger as patterns we can reconstruct. We cannot remember the future because it has not yet formed its patterns. The arrow of time, then, is deeply tied to the universe's tendency toward disorder. But this raises another question. Why was the universe so ordered to begin with? If entropy naturally increases, then in the far past, it must have been extraordinarily low. This mystery leads us into cosmology, where scientists study the conditions of the early universe. The prevailing view is that, shortly after the Big Bang, matter and energy were distributed in an unusually smooth and uniform way, setting the stage for entropy to increase over billions of years. Why the universe began in such a state is still an open question, one that touches on the deepest puzzles of physics. And yet, entropy is not the only arrow of time we know. There are other arrows that match its direction. The psychological arrow, which is the way we remember the past but not the future. The cosmological arrow, marked by the expansion of the universe. And the causal arrow, which reflects our experience that causes precede effects. All of these arrows point in the same direction, and all seem to be tied in one way or another to the thermodynamic arrow. Our memories form in the same direction that entropy increases. The universe expands as disorder grows. Causes and effects unfold in a way that matches the march toward greater entropy. But if entropy is the source of time's arrow, does that mean the flow we feel is an illusion? Some scientists think so. From this perspective, time does not actually move. All moments, past, present, and future, coexist in what is called a block universe. Our consciousness moves through these moments like a needle moving along a record, giving us the sensation of change. The laws of physics, in this view, do not single out a preferred direction for time. Only our experience does, shaped by the way information is stored and erased in our brains. Others argue that the arrow of time is more than an illusion, that it is a fundamental feature of the universe. In this view, the low entropy beginning of the cosmos set a kind of cosmic clock, and everything we experience is the unfolding of that initial condition. If the universe were to contract instead of expand, entropy might decrease, and our arrow of time could reverse. Though what that would mean for consciousness is something we can only speculate about. The arrow of time also presents fascinating implications for time travel. Traveling forward in time, at least in theory, is consistent with the second law. You can always move toward greater entropy. Traveling backward, however, would mean entering a state of lower entropy, which would require an improbable rearrangement of countless particles. This is why backward time travel appears far more difficult, if not impossible, according to our current understanding. Yet there are loopholes in theory. Regions of space-time, such as near-rotating black holes or hypothetical wormholes, where the usual rules might bend. In such exotic places, paths through space-time could allow a traveler to return to an earlier point in their own timeline. Whether entropy would permit such a journey without contradiction is one of the great open questions in physics. In the end, the arrow of time remains both a physical fact and a profound mystery. We can measure its effects, trace its connection to entropy, and predict its consequences, and yet we do not fully understand why it exists at all. Perhaps one day, in some far future, we will learn how to bend this arrow, to reverse its course, or step outside it entirely. But for now, it carries us forward, as it always has, from the known into the unknown. And in that steady motion lies the very fabric of our lives, the moments we cherish, the ones we regret, and the ones still waiting beyond the horizon. If ancient myths gave us the first dreams of traveling through time, science fiction has given those dreams their most vivid forms. Over the past 2 centuries, the idea of moving freely between past and future has been reimagined countless times, each version reflecting the hopes, fears, and questions of its age. In 1895, H.G. Wells published The Time Machine, a story that would define the modern image of time travel. His mechanical device, with its levers and dials, transformed the concept from myth into a kind of technology, something that could, at least in imagination, be built and operated. Wells's time traveler leaps forward into the distant future to witness the slow decay of the Earth, showing how time travel can be as much about confronting mortality as it is about adventure. In the decades that followed, science fiction embraced the theme with enthusiasm. Ray Bradbury's A Sound of Thunder imagined how small changes in the past could ripple forward into enormous consequences. The butterfly effect that has since become a cultural touchstone. Robert Heinlein explored time travel paradoxes with a mathematician's precision, while Madeleine L'Engle wove it into tales of love and courage in A Wrinkle in Time. Film and television brought time travel to even wider audiences. Doctor Who, which began in 1963, made the time traveller a familiar figure in popular culture. Eccentric, curious, and able to step into any moment in history or the far future. Back to the Future blended comedy, romance, and paradox in a way that still resonates today, while Terminator imagined time travel as a battlefield where the future and past fight for control over destiny. Each era's time travel stories reveal something about the time in which they were made. During the Cold War, many tales reflected anxiety about the future, dystopias avoided or caused by interference in the past. In more recent decades, with technology advancing at a dizzying pace, stories have explored questions of identity and choice. If you could relive a moment, would you make the same decision? Would you still be you? Popular culture has also expanded the idea beyond machines and wormholes. Films like Groundhog Day and Edge of Tomorrow play with loops, forcing characters to relive the same day until they change themselves. Others, like Interstellar, use the real physics of relativity to create emotional as well as scientific drama, showing that time travel can be as much about the heart as the mind. In all its forms, science fiction keeps time travel alive in our imaginations. It allows us to explore what if without breaking the laws of nature, at least not in reality. And perhaps that is its greatest gift, not just to entertain us, but to keep us wondering whether one day the impossible might become possible. If time travel ever became possible, it would open extraordinary possibilities, but also extraordinary problems. Among the most famous are the paradoxes, logical knots that challenge our understanding of cause and effect. These puzzles are more than just thought experiments. They are reminders that time may have rules we do not yet fully understand. The most famous of all is the grandfather paradox. Imagine you travel into the past and, intentionally or not, prevent your grandfather from meeting your grandmother. This means you would never be born. But if you were never born, how could you have traveled back in time to cause the change? The paradox creates a loop with no consistent outcome, suggesting that certain kinds of backward time travel might be impossible, or that the past cannot be changed once it has happened. A related puzzle is the causal loop, or bootstrap paradox. In this scenario, an object or piece of information is passed from the future into the past, only to become the very thing that causes it to exist in the first place. For example, a time traveler gives Shakespeare a copy of Hamlet before he has written it. Shakespeare publishes it as his own, and centuries later, the traveler reads it, goes back in time, and gives it to him. The play exists, but it has no true point of origin. It is caught in an eternal loop. Then there is the predestination paradox, where a time traveler's attempt to change the past only ensures that events happen exactly as they always did. This kind of paradox suggests that history is fixed, and that even our efforts to alter it are part of the chain of events leading to the present we know. In such a universe, the future might influence the past just as much as the past shapes the future. Physicists and philosophers have proposed various ways to resolve these paradoxes. One idea is the Novikov self-consistency principle, which says that the timeline is self-consistent. Events in the past cannot be changed in ways that create contradictions. In other words, if you travel back, you can interact with the past, but only in ways that are compatible with history as it already exists. Another possibility is the many worlds interpretation, in which traveling to the past creates a branching timeline. Any change you make produces a new version of reality, leaving your original timeline intact. This idea removes the contradictions, but it also means you can never truly fix your own past. You only create an alternate history. Paradoxes remind us that time travel is not just about machines or wormholes. It is about logic, causality, and the deep structure of reality. Whether they are obstacles or clues, they tell us one thing with certainty. If time travel is ever possible, it will not be as simple as stepping into a machine and setting the date. The past and future may have rules we have yet to imagine. When we think about time travel, we often imagine a single, continuous timeline, one unbroken thread from the past through the present to the future. But what if time is not a single thread at all? What if every choice, every possibility, spins off a new strand, creating a vast tapestry of alternate realities? This is the realm of the multiverse, a concept that reshapes how we think about time, causality, and our own place in the cosmos. In the many worlds interpretation of quantum mechanics, every possible outcome of a quantum event actually occurs, each in its own separate branch of reality. In this view, time travel doesn't change the past. It moves you into a different version of it. You might go back and prevent a disaster, but the disaster will still exist in the timeline you left behind. The new branch you create will unfold with your changes, while your original history remains untouched. This solves many of the logical paradoxes of time travel, but it comes at a cost. You cannot truly alter your own past. You can only create a new one. The people you knew in your original timeline will go on living exactly as before, unaware that you ever left. You, meanwhile, will find yourself in a version of reality where things are different, perhaps slightly, perhaps unimaginably so. Alternate realities also open the door to stranger possibilities. Some theories suggest that if the multiverse is real, it may contain versions of ourselves who made different choices, leading entirely different lives. Time travel in such a framework becomes not just a journey through moments, but through possibilities, a way to meet the selves we might have been. Then there are infinite loops, where time folds back on itself. In these scenarios, events repeat endlessly, either in exactly the same way each time or with subtle variations. A loop might trap a traveler in a single day, as in certain works of fiction, or it might encompass the entire universe, resetting reality after a vast cycle of eons. Philosophically, loops raise unsettling questions. If history repeats forever, are we truly making choices, or are we simply acting out a script we have followed countless times before? The multiverse and time loops challenge our sense of identity and continuity. If there are countless versions of us, each shaped by different events, which one is truly us? If time can fold back on itself, are we moving forward at all, or simply returning to where we began? Whether real or only a creation of imagination, these ideas expand our picture of time from a narrow, one-way road into something far more intricate. They suggest that time travel might not just mean visiting the past or future, but exploring an entire landscape of realities, some familiar, some alien, all connected by the mysterious structure of time itself. Time travel has a way of capturing the imagination like few other ideas. In literature and cinema, it serves not just as a plot device, but as a lens through which to explore identity, morality, and the fragility of human choices. Each story becomes a thought experiment, an invitation to ask, what if? H.G. Wells's The Time Machine is often seen as the starting point for modern time travel fiction. Published in 1895, it combined the spirit of Victorian scientific optimism with a haunting vision of humanity's distant future. Wells's machine was not merely a way to skip through years. It was a vehicle for confronting the consequences of time itself. The story set the tone for much of what would follow. Time travel as a means of examining society, not just escaping it. In the mid-20th century, writers like Ray Bradbury and Isaac Asimov brought time travel into the golden age of science fiction. Bradbury's A Sound of Thunder gave us the butterfly effect, the idea that even the smallest change in the past can ripple forward into massive consequences. Asimov explored the potential of time travel as a tool for preserving history in the end of eternity, where agents manipulate events to create a more stable world, raising questions about who gets to decide the shape of history. Cinema took these ideas and gave them visual life. Back to the Future turned time travel into a playful, character-driven adventure, while still wrestling with questions of fate and free will. The Terminator reimagined it as a battleground for the future, where machines and humans wage war across centuries. Looper blended action with philosophical inquiry, asking how far a person might go to change their own destiny. Some films have used time travel to explore the emotional weight of memory and loss. In Interstellar, time dilation becomes not just a scientific curiosity, but a source of heartbreak, as characters experience years passing for their loved ones in the blink of an eye. In Arrival, time perception itself is transformed, blurring the boundaries between past, present, and future in a meditation on love, choice, and acceptance. Television has embraced time travel's flexibility. Doctor Who has spun decades of stories from the simple premise of a traveler who can visit any place or time, blending whimsy with moral reflection. Shows like Dark and 12 Monkeys have pushed the genre into intricate puzzles of interwoven timelines, where cause and effect twist into complex knots. Across all these works, the enduring appeal of time travel lies in its ability to make the abstract tangible. It takes the mysteries of time, our deepest questions about change, choice, and consequence, and gives them form, whether in the brass levers of a Victorian machine, the shimmering portal of a science lab, or the quiet moment when a character decides whether to alter the course of history. For centuries, time travel lived only in myth and story. But in the last 100 years, physics has offered glimpses of how it might work in reality, not through magic or wishful thinking, but through the very structure of the universe itself. Einstein's theory of relativity was the first major breakthrough. Special relativity tells us that as you approach the speed of light, time for you slows relative to someone at rest. This isn't a trick of perception, it's a measurable effect. Astronauts aboard the International Space Station experience this on a tiny scale, aging fractions of a second less than people on Earth because of their speed. This is time travel into the future, built into the laws of physics. General relativity expands on this, showing that gravity also affects the passage of time. The stronger the gravitational field, the slower time runs. A clock on a mountain ticks faster than one at sea level, and a clock orbiting near a black hole would run far slower than one far away. In theory, if you could hover safely just outside a black hole's event horizon, hours for you could correspond to years or centuries in the outside universe. Step away, and you would have leapt far into the future. The challenge, of course, is going backward. Solutions to Einstein's equations suggest it might be possible under extreme conditions. One idea involves wormholes, hypothetical tunnels through space-time that could connect distant points and perhaps different times. If one end of a wormhole were moved at high speed and then brought back, time dilation could create a difference between its two ends, effectively making a shortcut between different moments. Another theoretical model comes from rotating black holes, or Kerr black holes. Their intense spin might allow for closed time-like curves, paths through space-time that loop back on themselves. In such a scenario, a traveler following the right trajectory could return to their own past. But these solutions remain speculative, and most physicists suspect that the universe has built-in safeguards, such as destructive feedback from quantum effects, to prevent paradoxes. Even if the engineering challenges were solved, and they are staggering, time travel would still be limited by energy, stability, and safety concerns. Constructing or maintaining a traversable wormhole, for example, might require exotic matter with negative energy density, something not yet observed in usable quantities. And any attempt to move through extreme gravitational environments comes with lethal hazards. Still, the fact that physics allows these possibilities, even on paper, is remarkable. It means that time travel is not purely fantasy. It exists, at least in theory, within the framework of known science. Whether humanity will ever harness it is an open question, but every experiment that measures time dilation, every observation of black holes and cosmic phenomena, brings us closer to understanding what might be possible. Time travel is often imagined as a technological triumph, a feat of physics and engineering, but if it ever became real, its most profound effects would not be measured in equations. They would be measured in human emotions. Imagine stepping into the past to see a loved one long gone. The joy of hearing their voice again might be shadowed by the knowledge that you cannot stay, or that your presence could alter the life you remember. Would you risk changing history for one more moment together? Traveling to the future might be just as complex. You could witness wonders, cures for diseases, cities in the sky, humanity reaching distant stars. But you might also see the fading of familiar places, the loss of traditions, the slow erosion of the world you know. The excitement of discovery could be mixed with a deep sense of alienation. Even short journeys could raise difficult questions. If you return to the present, carrying knowledge from another time, what would you do with it? Would you share it, knowing it could change everything, or keep it to yourself, fearing the consequences? The temptation to fix the past or guide the future would be immense, but so would the responsibility. Stories about time travel often return to this point. The traveler changes as much as the world does. Marty McFly learns to see his parents not just as parents, but as people. The Doctor carries the weight of centuries of choices. Characters trapped in time loops grow through repetition, discovering patience, empathy, or courage they never knew they had. There is also the matter of perspective. Experiencing time at a different pace could reshape our understanding of life itself. Relativity shows us that time is not the same for everyone, but living through that difference might change the way we value each moment. A single day in the present could become precious if you knew that, in another frame of reference, years might pass without you. On a larger scale, time travel could challenge our sense of identity. If you met a younger or older version of yourself, would they still feel like you? If you visited a timeline where you made different choices, would that other self be a stranger or a mirror? In the end, the human side of time travel is about more than physics. It is about memory, loss, hope, and the fragile thread of experience that ties us to one another. Even without machines, we already travel through time, carried forward second by second, making choices that ripple into the future. If we ever gain the ability to move freely along that thread, the greatest challenge will not be building the device. It will be deciding how and why to use it.